Hello, good day, students. You're welcome to class. All right, this is another day. We are looking at another question on the mensuration. And don't forget, the last time we solved some questions that involve triangles, rectangle, and also trapezium. So today we are going to continue from where we stopped in the last class. All right. So before we commence the class, I want you to invite your friends, let them know the class has started. Please just ensure that you share this video with your friends. And also don't forget, as you are joining the class, make sure you tap the like button. And if you are new on this channel, don't forget as well to click on the subscription button. I want us to look at this question and let's examine it within as you are joining so you can look at it. It is something you can solve, so you can just try the question on your own before we try it together. Okay, once you join the class, I want you to say "I" so that we know those people that are in the class. Okay, I think right now I can see Toyosi. You're welcome. Okay, okay. All right, Divine, you're welcome to class. Okay. Yes, let's invite others. So as you are entering, I want you to look at the question and make a good attempt. Try and solve the problem. If you can get the answer before we solve it together. Okay. Yes, is there anybody with the answer? If you have an answer, you can drop it in the comment section. Okay. All right, don't forget as you are entering, make sure you say hi. Let's know those that are in class. Okay. And don't forget, as you are joining, make sure you tap the like button. So that shows that we have good number of students in the class. Okay. All right. Is there anybody with the answer? If you have an answer, you can drop it in the comment section. Let's see. Anyone? Okay. All right. I think we should solve the problem together so that we won't waste much time on the question. Right. Okay, so now let's look at the question. The question is under trapezium. Now look at the figure here. Now the question says that we should find the area of the trapezium. So that means this is the trapezium. Now let's examine the trapezium. We have two parallel lines. We have line AB and line DC. Okay, so we have two sides and we are also given the height. And the height of the trapezium, that is the distance between the two parallel lines. Okay, so with all this information, we should be able to find area of trapezium. Now, if I don't know the formula for calculating area of trapezium, that may be a little bit difficult for me to do. All right, so now let's look at it. Formula for finding area of a trapezium is half A plus B times H. Okay, can you see that? All right, where A and B are the two sides, parallel sides of the trapezium. Now look at the trapezium now. So we have two sides, two parallel sides. So this is the first side and this is the second side. Okay, good. So now here in the question we are given that A, the first side is 10 centimeter, while the second side is what? 6 centimeter. All right. The height has been given. What's the height? Height is 8 centimeter. So then we can easily calculate the area. So we have area equals to 1/2 Now we have 10 plus 16, okay, plus 6. B is 6 centimeter, okay? So this is supposed to be 6 centimeters. So plus 6, right, times h. H is 8. Okay? So now we have this to be 1 over 2. Now when you add what we have in the bracket together, you have 16, okay, times 8. Now 2 goes here, 1, 2 goes here, 8. Okay, so we now have 8 times 8. That gives you 64 centimeters squared. So that is what we have for that. All right, now the next thing now is you have to find the ratio of the area of triangle AEB and triangle CED. Okay, so that's what we want to do now. All right, so now the first thing I'm going to do now is I'm going to be using principle of similar triangles. Okay, now when you look at this, whenever you are given parallel lines of this form, and you have a transversal, okay, on it like this, a transversal. Now the angle here is alternate to this angle. This angle here is alternate to this, and if this is A, this is going to be A. So, and alternate angles are what? Are equal. All right, so in that case, now let's look at this diagram there. We can see the diagonals. Okay, so now this angle here is alternate to this angle here. You can see, you can bring out Z like this. So the same thing also applies to this angle here, angle A, is alternate to this angle here, angle C. And then whenever you have two lines, straight line crossing each other, the angle here is the same thing as the angle here because they are vertically opposites. And the vertically opposite angles are equal. So that means that this angle here is vertically opposite to this angle here. Okay. So now, where are we heading to? Now, I want to show that we have similar triangles. We have similar triangles. Let me clean this. We have similar triangles in this diagram. Similar triangles. So you will see that triangle A, now let's call this point E. B, E, A, or you say A, E, B is similar to triangle DEC. DEC. Okay, or you say CED. They are similar. All right, because the angle here, angle C in this triangle is the same thing as this angle here. The angle E here is the same thing here. Angle D here is the same thing as what we have here. So that means the two triangles are similar. So if they are similar, it means their sides too will correspond to each other. So now all I need to do now, because what I want here now, I want to find the ratio of this of the area of the two triangles, this and this. So let me find the ratio of the sides. Okay, so the ratio of the side, I have side AB to that of DC is equals to 10 to 6. Can you see that? Now look at it. In this triangle AEB, all right, the side AB corresponds to side DC. Okay, or you say CD. So say the same thing. So these two sides correspond to each other. So of course now we can reduce that to what? 5 over 3. So that means that AB, length AB ratio DC is equals to 5 ratio 3. You get that? And don't forget, this side is in this triangle, triangle AEB. That is where we have length AB. And this DC is in this second triangle, triangle CED. All right. So now what we just need to do is just to square this ratio. Now once we square it, we have AB ratio DC. When you square it, we have 5 square to 3 square. Now this is the ratio of the triangle. Okay, this is the ratio of the triangle. Once you square the ratio of the sides, it's going to give you the ratio of the triangle, of the area, sorry, area of the triangle. All right. So now we now say ratio of the area of triangle AEB to that of triangle CED is equals to 25 to what? To 9. You just square this. 5 times 5 is 25. 3 times 3 is 9. So that is the ratio of the area of the triangle. So I hope we all get the explanation for this. Now, before I move down to the next one, is there anyone that have any question or reservation based on what we have done before we move on to the next question? So you can drop that in the comment section so that I quickly react to that. Okay. Okay, if there's no reaction on that, okay, so we can move down to the next question. Let's move down to the next question. Please, as you are joining, ensure you tap the like button, and if you have not subscribed, so ensure you subscribe so that anytime we're on here, you'll be notified. Okay, all right. So let's move down to the next question. All right, this is another similar question. Now let's quickly solve this problem together. Now let's look at the question. Now a trapezium has area 96 centimeters squared. A diagonal divides it into 2 triangles. Now, find the area of the triangles if the parallelogram or the parallel sides are 6 centimeter and 10 centimeter. I hope you understand that. Now let us just sketch the trapezium. Let's sketch the trapezium. So the trapezium looks like this. Okay, we have the two parallel lines. Okay, and we are given the sides. We have 6 centimeter and 10 centimeter. So these are the two sides. Okay. All right. So now we're also given the area. Area is 96 centimeters square. Okay. So now the question wants us to find the area of the triangles. That is when a diagonal, cross this. So let's draw a diagonal this way. Okay, it's just like the example we just did now. So you will see that this triangle, now let's label the triangle. We have A, B, C, D. Now you will see that this side, when you consider this triangle, look at this triangle, is similar to the second triangle. How did we get that? I explained that in the former example, the last example we did. I said now that this angle here is alternate to this angle. So that means they are equal. The same thing also applies to the second one. Which other one? If you have it this way, right? You have it this way. So this angle here will also be similar to this. All right. So the implication of that is this side AB will be similar to CD. All right. I hope you understand that. So from here, I can just bring out a ratio. So I will say length AB to that of CD is equals to 6 over 5. And that's 6 over 10, sorry. And that's the same thing as what? 3 over 5. All right. When you simplify this, 2 goes here is 3, 2 goes here is 5. All right. So this is the ratio of the sides. So we have AB to CD equals to 3:5. Now, let's find the total ratio. So total ratio equals to 3 plus 5. And that gives us what? That gives us 8. Now, what we need to get is the area of this triangle and this second one. Of course, now, one will be bigger than the other. So that means we are going to have a bigger triangle and smaller triangle. So now let's get the area of the smaller triangle. Don't forget, the total area of this trapezium that gave birth to two triangles is what? 96 centimeters square. Do you understand now? So that means we are dividing this area into two parts. All right, we are dividing the area into two parts. So the addition of the area of the two triangles must be equal to 96 centimeters square. I hope you know that. All right, so now let's now get area of the smaller triangle. Okay, now is going to be, now you can see it will correspond to the smaller side, which is 3. So that's going to be 3 over 8, the total ratio times the total area, which is 96. All right, so we now have 8 goes here 1, 8 goes here is what? Is 12. So 3 times 12, that gives you what? That's 36 centimeters square. So this is going to be the area of the smaller triangle. the smaller triangle. So it's either this or this. So area of the smaller triangle. All right, so now to get the area of the bigger triangle, that one is straightforward. It's either you say 5 over 8 times 96, or you just say 96 minus 36. Since the addition should give us 90, see the addition of the two areas should give us 96. So that means area of the bigger triangle. So area of the bigger triangle will be equals to 96 minus 36. Okay, 96 minus 36, and that gives us what? That gives us 60 centimeter square. So that is the answer to that problem. All right, so now we are moving down to another interesting plane shape. Okay, so that is circle. So I will need you to pay attention to this because I want to try and look at different things, the properties of circle, and also all the formulas that surrounds circle. Okay. All right. Now, can we see the figure on the board? I want to believe every one of you are familiar with the figure on the board. All right. So the figure on the board is a circle. A circle. So like I used to tell students, you see, it's always good to understand everything that surrounds the plane shapes that you want to solve the problem. If you don't know the properties, it will be very difficult for you to solve problems on it. All right. So now I want us to pay attention to all I'm going to say about circle now. So it's going to help us now to solve some problems. All right. Now let us look at the circle. I'm going to begin to point out parts of the circle. Now the first thing I want to show you in this circle now is the center of the circle. The center of the circle. You can see that is where we have points O. Now the center of the circle, you may need to jot it down if you like. The center of the circle is the middle of the circle. The middle of the circle. That is what we call the center of the circle. And in most cases, we represent the center of the circle with O. So O represents center of the circle. Okay. All right. So now the next thing I want to show you is the radius. The radius. The radius is the shortest distance between the center of the circle and any part of the circumference of the circle. Now, circumference of the circle is the boundary of the circle. Okay, so if I say what is circumference of a circle now, the term is the boundary of the circle. So is that line that describes the circle. All right. So now the shortest distance between the center of the circle and any part of the circumference of the circle is what we call the radius. All right. So, or I say the radius is a straight line that is joining the center of the circle and any part of the circumference, any point on the circumference. So that is what we call the radius of a circle. I hope you understand that. Now, the next thing I want to show you now is an arc. An arc. So what do we call an arc? Arc. An arc is a fraction of a circle, so circumference of a circle. Fraction of circumference of a circle. Now, when I say fraction of something, that means part of it. Now, look at it. Now, the line that describes the circle is like this. So, if I cut out of it now, you see, I've cut that line that describes the circle. So, this is what we call arc. This is also arc because it's fraction of a complete circumference of a circle. All right. So, this is what we call an arc. This is an arc. This is also an arc. So, because they are both fraction of a complete circumference of a circle, right? But this is called minor arc. The smaller one is called the minor arc. Why this big arc is called the major? Okay, I think you can easily get that. Major arc. Okay, so if you add the minor and the major arc together, it gives you a complete circumference of a circle. I believe you understand that. Okay, so another thing I want to show you is the diameter of a circle. Now look at this. This is diameter. Diameter is the line that divides the circle into two equal parts. Is the line that bisects the circle. Okay, that divides the circle into two equal parts. All right, so look at it now. It's dividing this circle, complete circle, is divided into two equal parts. So any straight line that is dividing the circle into two equal parts, okay, we call such line the diameter. Or in another word, we say is a straight line that passes through the center of the circle and touches the circumference of a circle at 2 points. At 2 points C and what? And D. So once we have any straight line that passes through the center of the circle and touches the circumference of that same circle at 2 points, now such line is called the diameter. The diameter. So it's called the diameter. Okay. So now the next thing we need to know, don't forget I said earlier that the line from the center of the circle to the circumference is called the radius. Now this is radius. This is also radius. Now the implication of that is diameter is the same thing as 2 radii. So we have diameter is the same thing as 2 radii. Because in a diameter, you are going to have 2 radii. So I want you to take note of this. Okay. All right. So the next thing I want you to know is what we call the chord. The chord. Now the chord is a straight line that divides the circle into two unequal parts. It divides the circle into two unequal parts. Unlike your diameter, diameter will divide the straight line that divides the circle into two equal parts, while the chord is a straight line that divides the circle into two unequal parts. All right, or I say is a line that touches the circumference of a circle at 2 points but doesn't pass through the center of a circle. You see, you can always draw any line that will touch the circumference of the circle. If that line, that straight line did not pass through the center of the circle, is a chord. So if I draw any line now, I have a circle and this is the center. I draw a line this way. It looks as if it divides into two parts, but if it does not touch the center of the circle, it is called a chord. So this is a chord. This line, this length is called a chord. All right. So the next thing is what we call the segments. The segments. Now you see, when a chord divides the circle into two unequal parts, so it divides them into segments, two segments. You divide them into two segments. Now the two segments are named major segment and minor segment. Now like this, now this is a chord. Now divide this circle into two parts. We have a part here and another up here. So now this one is called the minor segment. Why the bigger one, this part is called the major segment. All right. So every one of you now know what we call a segment. We have major segment and minor segments. So this is the major segment, this is minor segment. All right. So what else do we need to look at? Now, another thing we need to look at now is, let's say, the sector of a circle. Now look at it. If I have a center of a circle and I have two radii like this, now this part is called the sector. Sector of the circle. This part is called the sector. So the sector is bounded by two radii and an arc. Look at it. We have two radii and one arc. Can you see that now? So it's encompassed by two radii and one arc. So this portion now is called a sector. The same thing also applies to this upper part. You can see this upper part is also bounded by these two radii and a major arc. So that makes this to be a major sector. And this is minor sector. I hope you understand that. All right. Now, this minor sector will subtend an angle. Subtend this angle at the center of the circle. While this bigger sector subtends this angle here at the center of the circle. All right. I want to believe you guys are learning. All right. So that is all we need to know about parts of a circle. All right, so we can now go ahead and look at the formulas. Okay, now let's start from the perimeter and area of a circle. Now, perimeter of a circle is 2 pi r. And area of a circle is pi r squared. Please, I need you to take note of these two formulas. Perimeter of a circle is also the circumference of a circle, is the boundary of the circle. Do you understand now? So we can use it interchangeably. So, okay. So circumference of a circle is the perimeter of a circle and is also the what? The boundary of the circle. Okay. So, and the formula is 2 pi r. So now area of the circle is pi r squared. All right. So now that now takes me to length of an arc. How do we get length of an arc? We need to get length of an arc. How do we get length of an arc? Don't forget, we said an arc is a fraction of circumference of a circle. Now, so we now write that length of an arc, length of arc, the formula for finding length of an arc is going to be, let's say we have arc AB and it subtends an angle at the center of the circle. Okay, let's say the angle subtended at the center of the circle is theta. Okay, so this is center of the circle. Let's represent that with A. So we want to get this length of an arc. Don't forget, an arc is a fraction of circumference of the circle. So I will now write length of arc is going to be theta over 360 times 2 pi r. 2 pi r. Can you see that now? Since the fraction of the arc also depends on the center, the angle at the center here. So we have to write theta over 360 times the total length of the circumference, and that is 2 pi r. You can see the connection between length of an arc and the circumference of a circle, because we say length of an arc is a fraction of circumference of a circle. So now this is the formula for circumference of the circle. So just put theta over 360. That's all. Okay, I want to believe we all get that. Now let us now look at another one, which is a sector. Sector. Let's say area of the sector now. Area of a sector. Now, area of a sector. Now, if we have a circle of this form, this is what we call a sector. Here, the sector. Now, you will see that this sector is fraction of area of a circle because it's just an area here. Area of, or a fraction of area of the whole circle. I hope you guys are getting me all right now. So that means a sector is fraction of area of a circle. So this sector also subtends an angle theta at the center of the circle O. So now the formula for area of sector of a circle will also be theta over 360 times pi r squared. Okay, can you see the connection between the two? So you don't really need to cram the formula. Just understand the connection, the relationship. All right. So if you are talking about arc, that means you're talking about perimeter of a circle. You are talking about sector. You are talking about area of the circle. You can see now. These are two basic formula you need to understand. So I want you to write this one in your jotter. So anytime you want to find length of an arc, you don't need to begin to rack your brain. So just get the relationship and then you bring it out. Okay, so can we move on now? All right. So the next thing I want us to look at now is, let's say you want to find perimeter of a sector. How do you find perimeter of a sector? Now, don't forget, a sector looks like this. Minor sector. It looks like this. Now, if I should ask you, what makes the boundary of a sector? You know, what makes the boundary of the sector? So we have a radius here, a radius, and an arc here. So, and don't forget when we said perimeter, that it is the addition of the length of the boundary. Okay, these are the boundaries. We have R, and L. So once we add everything together, it becomes the perimeter of the sector. So if you want to find the perimeter of the sector, so that means I need to add R plus length of an arc. So now can we write the formula I have now? So we have perimeter of a sector. Perimeter of a sector will give you 2 radii. We have 2 radii plus L. 2 radii plus L. Don't forget that L is length of an arc. So what's the formula for length of an arc? You have it here. So you can just add it to it. So I can simply write 2R plus theta over 360 times 2 pi r. Now this is the formula for calculating perimeter of a sector. So you can write this one down. Okay, perimeter of a sector. Okay, so that is that. Now the next thing I also want to show you is perimeter of a segment. A segment. I show you what a segment is. I said a segment is a fraction of area of a circle that is divided by a chord. Do you understand now? So a chord is that line that divides the circle into 2 segments. A chord divides the circle into 2 segments. So we can have major and minor segments. Okay. So now what we want to do now is, let's derive a formula for calculating perimeter of a segment. How does a segment look like? Let's look at minor segments. If you have a circle this way, this is the center, and you have a chord that divides it. So this place is what we call a segment. So if I want to get the perimeter of a segment, okay, can you tell me? So what are the things I'm going to add together to give me perimeter of a segment? So if you know the answer to that, because you must know how we derive this formula, so that will help you now to be able to connect things together. All right, this is where many students will have issues, because they don't take time to understand how the formula is being derived. And if you don't understand it, once question is asked, you start mixing things up and it becomes complex. I don't want any one of you to have any issue as regarding that. That is why I am taking time to explain the formula. So once you understand the formula, you can derive it on your own. Then once any question comes, you should be able to solve conveniently. All right. So can you see now? Now I'm asking you, because we are doing it together now. So what and what must be added together to give us perimeter of a segment? So I want you to drop your answer in the comment section. I've been talking since. So yes, drop your answer in the comment section. Let's see what you have for that. Yes. Anybody? Yeah, thank you, Divine. Yes, I need you to drop an answer. Yes, what must be added together? to have the perimeter of a segment. You can see you have it on the board there. What must be added together to have the perimeter of a segment? Motorayo, you are welcome. I can see you. Gabriel, okay, you are welcome. Been a long time. All right. So can you attend to that question? Yes. Do we have free scores here? Okay. What must be added together to give perimeter of a segment? Perimeter of a segment. So if you know what a segment is, so you should be able to tell me what must be added together to give me the perimeter of a segment. All right, okay, Riscott have dropped an answer. The length of an arc and a chord. Okay, that's an answer. Is anybody that have anything contrary to that? Is anyone that have anything contrary to that? Yes. Okay. Adewusi, yes. Are you dropping an answer? Oh, major and minor segments. Oh, okay, okay. Because of our time, all right, our time is seriously running. All right, now let's look at it. Now look at a segment. See, this is a segment that is shaded now, so you can see segment shaded. Just like this chord said, this is a chord. You can call it AB, chord AB, and arc. Look at this arc. This is arc AB. You understand? And that is what actually bounded this area. All right. If I'm to find the perimeter of this chord now, of this segment, so I will add this and this curve together. That gives me the perimeter. So in that case, since we know what we are adding together to get perimeter of the segment, so I need to know the formula for calculating length of a chord. Length of a chord, and that is what I'm going to give you now. Length of a chord, length of chord, and that gives you 2r sine theta over 2. Okay, this is the formula for finding length of a chord. So you need to master this. So this formula for finding length of a chord. So now, if I now want to get perimeter of a segment, now you know what I'm adding together? The formula for this length plus an arc. This. So I have perimeter of a segment equals to length of an arc. This one we have theta over 360 times 2 pi r plus 2r sine theta over 2. Okay, so now this is the formula for finding perimeter of a segment. So you just add this and this together. Can you see? It seems this formula are just too many. Honestly, you don't need to cram all these things. You don't need to cram them. All you just need to do, just master how all these things are being derived. So once you're able to get that, you find everything easy. All right, so I'm going to be stopping here for today. Okay, so tomorrow we are going to look at one or two formulas again before we now start solving problems. So that is the reason why I said we are doing a lot under circle. Okay, so we are going to also get the formula for finding. Okay, we've gotten that of segment of a circle. So we also find how we can get area of a segment. You see the area of the segment that we have here. Can see area of the segment. This one, how do we get area of the segment? So that I'm going to explain in the next class. So please, I want to implore you, don't miss the next class. So all these details, once you understand them, you find it very easy to solve any problem under circle. You understand now? Area, perimeter, any question, you should be able to solve it conveniently since you already understand the formulas that is connected. So tomorrow I'm going to show you how to get the formula for calculating area of a segment. How do we get formula for area of a segment? Okay, probably let me give you that as an assignment. So find out how we can arrive at area of a segment. So once we're able to do that, we can now begin to solve our problem. So I want to believe you guys have learned one or two things today. And please don't forget, all these formulas, you can put them in your jotter. Make sure you master them against the next class. Though before we start the class, I'll quickly remind us of all these formulas because they are needed to solve our problems. So try and sit down and master them. Okay, so thank you very much. And I just want to say this: if you have not subscribed to this channel, please make sure you do that. And don't forget to tap the like button. Also, don't forget to invite your friends. Let your friends know about this class. Let them also come and learn and also be part of what we are all enjoying. And I also want to say this: if you have any questions that you want me to attend to, so you can always get them down and drop the question. I'm going to drop my number here for those that doesn't have it. So on my WhatsApp, so you can drop your question 234 80391794. 65. Okay, so you can drop your question there based on what we are doing currently. Or if you have any other questions, so we can always trash them here. So once you drop the question, so once we come here, we try and look at the question. So I want to believe you guys have learned a lot today. So please make sure that you keep on practicing. Keep practicing. So the more you practice, the better you become. Thank you very much. I love you guys. Lee Scott, Moturayo, Gabriel, Toyosi, and others. I can't really remember your name all. Okay, so take good care of yourself. Bye bye.